Hello everyone, today we're going to resolve LeetCode daily problem number 3342. Find minimum time to reach last room 2. It's the second problem in this sequence of finding the last room with minimum time. So it's a minimum problem. We have a dungeon and XM rooms arranged at the grid and given to the array move time of size n xm, where move time I and j represent the minimum time in seconds when you can start moving to that room. You start from the room 0, 0 at the time 0 and can move to adjustment room, more neighboring rooms. Between adjustment rooms take 1 second from one move and 2 seconds for the next, alternative between the two. So the return minimum time to reach the room with n minus 1 and minus 1. So two rooms are adjustment if they share a common wall, either horizontal or vertically. And here we have a few examples. For example, if input 0, 4 and 4, 4, the output will be 7, as we start at time of 4 and move from room 0, 0 to room 1, 4 in 1 second, making it time 5. So at time 5, we move from room 1, 0 to room 1, 1 in 2 seconds, making the output 7. Here I have also example with all zeros. So we will have return of 6 because the minimum return time required to check it all rooms is 6 seconds. So at the time of 0, we move from room 0, 0 to room 1, 0, 1 second. Then we have time 1. So the next move from room 1, 0 to room 1, 1 is 2 seconds, and we have time 3 seconds. Then we move from room 1, 1 to room 1, 2 in 1 second, increasing time to 4. And lastly, we make a move from room 1, 2 to room 1, 3 in 2 seconds. And here we have the last example with 0, 1 and 1, 2, which output will be 4. So we have quite big constraints, though it will be better to resolve it in complex way. So to express this way in easy understandable, let's listen a good story. So in quiet Abbey of Focus, monks navigate a labyrinth of cloistered cells, each cell sealed by a lock that opens only after a certain hour. Brother Dijkstra, a disciple of Cal Newport's philosophy of deep work, knew that shallow wandering would never guide him swiftly to the great chapel of the maid's exit. Instead, he charted a precise path. At each crossroads, he noted the next 4 doorways: north, south, east, west. Then chose the corridor whose door he could unlock soonest, and whose walls would alternate between a quick step 1 second and a measured pace 2 seconds. By tracking these unlock times in priority queue and marking corridors once traversed, Brother Dijkstra reached the exit in minimum time, deep focused, rewarded by efficiency. So as you understand from Brother Dijkstra, our algorithm will be Dijkstra, the shortest path, adapted for time gated, not with alternative step cost. And we also will use data structure of my mean heap queue, to always expand the room reachable at the earliest time. For the complexity, time complexity will be big of n and m, log of n and m, so itself encoded decoded at the most once, and heap operation cost log of time rooms. And space complexity will be, in worst case scenario, big of n and m. So let's implement our Dijkstra solution. We will start with declaring our n and m variables, which will be equal to length of rows and length of columns. And next, length of move time column. Next, we will need our 4 direction, down, right, up, and left. We make it theirs, should be equal to 1, 0, to down, 0, 1, to right, -1, 0, to up, and lastly 0, -1 to left. Then we will need our min heap to store tuples. So we will store current time, x and y, which will be represented to our place where we at the moment, and next step cost. So how much in seconds will be cost in the next step. So heap will be equal to 0, 0, 0, and 1. Then we will mark started as visited by setting it to -1. So move time at the beginning, 0 and 0, will be equal to -1. So as understandable, if we start from the room, this room already visited. Then we will run a while loop for heap, declare time, declare x and y as our direction, and we declare step cost, which equal to heap q, heap pop, heap. So we will try each neighbor. So for the x and then y in their directions. So nx and y will be equal to x plus dx and y plus dy. Next, we will run our if statement to skip out boundary or already visited. For that, we will use continue. So if not 0 less than equal to nx less than and 0 less than equal to and y and less than m, then we continue, skip this loop. And the next, if move time nx and y less than 0, which means -1, then continue. It's already visited. So next we will mark our unlock time, which will be equal to move time of nx and y. After that, we will need our arrival. Arrival will be equal to max time, unlock time, plus the cost of our step. Then we run again if check. So if our conditions are true, so nx equal to n -1 and y equal to m -1, then we will return arrival. After that, we incur neighbors, so flip 1 and 2 for next move. So heap q, heap push, heap, then arrival, nx and y, and 3 minus step cost, and mark visited. So more time of nx and y will be equal to -1. And lastly, it's not necessary because by problem constraints we will never reach that, but generally the practice is just return -1. And let's run our code. It's passed our test. Then here we see the output. Expected, everything is fine, and let's submit. And it's very efficient. So by following deep work, brother Dijkstra was able to resolve this complex puzzle and find his skull inside of Chapel. That's why we also should concentrate on deep things and deep understanding. Thank you for your attention. If you have any questions, feel free to leave them down below. And have a nice day. Bye.